Hi everyone, Mr. Ford here. I'm going to go over the additional practice QQT long response question for the exam. This is the one with the merry-go-round and the book on the seat. So the first question was to determine the period of revolution of the book. Something to keep in mind, this is not rotational motion, this is circular motion. So from the graph, we have some information. We have the horizontal displacement on our y-axis and the time. So since we're looking for period, we're essentially looking for time for one revolution. So whether you connect it to pre-calc with this graph, we're looking for one complete 2 pi. Or if we look at, this is our starting position, and we're going to look to see where it starts to make one full wavelength. So that full period there. So that distance is from here, or I'm sorry, the time is from here to here, where you need to scale the graph, and every little block is 20 seconds, so it's going to be 120 seconds or 2 minutes. Another way to look at that might be to look at the peaks, right? From the crest to the crest, there would be some estimating there. But when you have the opportunity to find something that is exactly on the axis, so you can see the numbers in the grid, please do so. So that was the first thing you had to do. So of the total 12 points, you got 1 point just stating that it was 120 seconds or 2 minutes. No explanation needed. For the second part of A, you had to calculate the tangential speed or actual speed of the the book, which, just thinking, speed, distance over time, and the distance that this book moves is in a circle. So we're going to look at the circumference, or 2 pi r. So that's where this equation comes from, is the circumference divided by the time of 120 seconds that we have. So the problem is getting the radius. So in the picture, there's no radius, but where we're going to get that from is from our graph. So something to keep in mind is, as you're going through problems for the AP exam, think of like why they're giving you this information. Why are they giving us our horizontal displacement? It's not there for just, for fun. It's there to be used later on. So we're going to be looking at, if we have like a picture of our thing here, it's the horizontal displacement. So if you remember watching that one Edpuzzle video where they, not Edpuzzle, but Flipping Physics, where they related harmonic motion to circular motion, I think that was a pretty cool video. But we're essentially looking at how much this point is essentially going to be going back and forth, kind of like the graph, and they just make it a horizontal graph. So if this is the center, and they tell us we're looking for the maximum displacement would be the radius, right? So that first peak is going to be 30 meters, which makes sense if it's kind of like a merry-go-round thing. That's a pretty big amusement park ride. So that's where they get the 30 meters. So plugging that in, 2 pi times 30 divided by 120, you get about 1.6 or 1.57 meters per second for your speed. So this part was worth 2 points. You got 1 point for the full answer, which, if you got the full answer, chances are you're going to get both points. They were noting, though, that they wanted you to, wrong thing here. Wanted you to, let's go, that's good color. Mention or use that 30. So that's recognizing that that is the radius, and you took that from the graph. So if you were missing that 30 meters, you probably would have only gotten 1 point if you did everything. You just wouldn't have gotten the full answer. Or if you did like 2 pi over t, you may have gotten 1 point. For B, we're drawing a force diagram. Keep in mind, you're not going to have to do this on this year's exam, but conceptually it's good to understand. So this one was worth 3 points. I thought this was a very easy 3 points to get. And since it is circular motion, the net force, or the centripetal force, needs to be pointed towards the center of that circle. So at the position of the book at the bottom, of the merry-go-round, the upward force needs to be bigger. So they wanted you to identify that as normal force, and the other force is gravity pulling down. And so where the 3 points came in is identifying normal, gravity, and showing that normal was bigger. So make sure when you're either selecting or drawing force diagrams that it's noticeably bigger of an arrow or a line. They did mention that as far as the 3 points go, if you drew additional forces, like friction on there, then you wouldn't have gotten that third point. So keep in mind the College Board only wants to see real forces and not the horizontal and vertical components of forces if you asked to draw a force diagram. Part 2 of that, they were asking, let's see, which way is the net force, up, down, or no direction, since they would cancel out. And they want you to explain, notice without deriving any equations, explain the reasoning. So the net force is up. You simply have to mention that it's, circular motion, and the net force or centripetal force needs to be going towards the center of the circle. So therefore, the overall net force needs to be going up since the center circle is above the book. So that was just 1 point as long as you selected up and gave a correct explanation. Part C, you had to derive an equation for this normal force, this force on the book by the seat in specific terms. So M subscript B, V subscript B, radius R. Keeping in mind, if you just write M or V, or maybe even lowercase r, you might not be assigned points. They want you to specifically address forces, not just say F for force. And they are not telling you to define it as normal force because that's part of the previous question. So they're not going to give you the answer in part C for the other ones, but you still should note that it is the normal force. So we're looking at Newton's second law for circles. So sum of forces, or even like centripetal force if you want, is ma, and specifying it for centripetal acceleration. So for using Newton's second law for circles, you got 1 point of the 3. For identifying centripetal acceleration as v squared over r. So note you could come directly out and say this, or by your notation of me stating a subscript c and then plugging that in. That's showing that I have an understanding of what centripetal acceleration is, and I'm not just writing a, and I'm not just writing an equation, F equals mv squared over r. The third point is getting a full correct answer. If you can simplify it, but this part here you would have gotten the points as well. Making sure, so the one note I want to make sure that you guys understand is when we're using numbers, we would plug in our negative 9.8 here when we would do our problem, when we plug in the numbers. If you're just deriving an equation in terms of variables, make sure you are saying like these forces are adding or subtracting. So we know that our force of gravity is going down, so we need to assign that negative here. So that when the end, if we're just comparing ratios or relative values, there's a reasoning why this is going to be positive and not negative. So either of these would have given you that third point. And the last part, which was kind of easy, I think, if you got the other ones right, is, again, at the lowest point, is the force that the bench exerts on the book greater than, less than, or equal to the weight of the book? And you would have to say greater than, and give an explanation based upon the previous part B2 and C to support your answer. So as long as you say greater than, you got a point. And as long as you addressed both of those parts, B1 or B2 and C, and essentially they're saying that the net force needs to, go towards the center of the circle, and that our normal force needs to be bigger than the force due to gravity, you would have gotten those 2 points. So hopefully that helped. For those that took it, the one thing to keep in mind is answer the questions asked of you. There was a person that for part C, they specifically tell you, do not substitute any numerical values for variables or physical constants. So they want you to use those variables. Don't put numbers in. If you do, they might not give you that point. On your midterm, I think we gave you those points. On here, there's nothing specific in the scoring guide to not add those points. But if it is saying like this is, your final answer is this, what we have here, and if you have something varying from that, like you have plus 9.8 here, that's not that same answer. And again, that's just following directions. So again, the AP exam is identifying how well you understand physics, and understanding if it says do not use a physical constant as numbers, just put that constant in there. Make sure you do so. If you have any questions, please let me know. Sign up for office hours, and we may talk later today or tomorrow.